Hey YouTube, just a bit of a follow-up video. Something that was shown to me by the rep from 3D Agencies who does the imports of the Unity meters here in South Africa that I found quite interesting is a lot of these Unity meters we don't know too much about. Now, last time I did a review on this meter, we looked at all the insides, how everything comes together, how it all works, etc. We didn't really take a deep look inside to see how the quality of construction is with this UT71D. We're going to take a look at that today. And what we're also going to do is I'm going to show you a shortcut which I was shown, which was quite interesting. Now, if you go across to volts, you have your 40,000 count display. And it updates relatively slow. It's not very fast, you can see. It's maybe twice a second, maybe if you're lucky 3 times a second. But I was shown a trick. If you hold down the blue button and switch the meter on, you're going into a hyper update mode, and if you look there, it looks like it's updating possibly 5 times a second. I'm not sure what the exact spec is, but it's extremely fast. I mean, if I was now to connect this onto a variable power supply, you would see exactly what I'm talking about by very fast updating. I'm just gonna, it's 5 odd volts. Okay, but now as you rotate, look how quickly that is updating. It's incredibly fast, but you do lose a little bit of resolution when you do this. Then to get back to normal mode, you switch off back on and you're back to your 40,000 count mode. So I just thought that was something interesting to point out about this meter. Now we're going to go inside and we're going to take a look and see how the inside of this is constructed. And we're going to compare it against an image that I have of one of the Unity Pro multimeters. Now I'm not allowed to show too close, so that otherwise on the Unity Pro you might be able to see some proprietary hardware, etc. And it's not my meters, so unfortunately there's not much I can do about that. But for now we can take a look inside here and see what we can see. Right, so here we have the inside of the meter. Now the interesting thing to note is these meters do have some sort of screening over here, but the quality of it is pretty bad. I'll get in a bit closer and show you guys now. Although the sockets look like they can take high energy HPC fuses or something like that, they don't install those sockets. They install these normal glass fuse sockets for your milliamps, microamps, and of course your amps range. And you've got a jumper selector here. I have no idea what that's for. Quite a lot of capacitive components. It looks like there's some form of capacitor adjustment inside here, variable capacitor, and I would think that the microprocessor, etc., are underneath here. And then of course here we have a multi-turn pot. But let's get in a little bit closer and you'll see why I have my doubts about the quality of a lot of these things. Okay, yeah, you have the 9-volt battery which connects through, it comes through the board over here and it comes down and back through the board again, and then it would solder in somewhere over here on the other side. I'm not going to pull the whole board out. You've got a contact here which I would assume would be for the beeper on the back of, no it's not, this one's for the beeper. This one's just to connect the this is just to connect the a ground, basically a signal ground, because it's coming from the ground terminal to give you some form of this metal inside here. It's not really done very nicely, but you get the gist of it. The terminals themselves are just single point soldered. These seem to be some form of testing points, or what would you call it, like probe alert sort of things. So there must be some sort of sense circuitry for these things, because you've got your primary points and then this connects down to the board via a header connection over here. You've got 2 current shunts in parallel. Weird. Okay, I'll live with it. This is just that thin metal cheap contacts that are soldered down and pushed into a molded plastic on the chassis. So this is actually on the chassis of the meter, so it's not a separate entity. We've got a couple of through-hole passive components over here, the resistor over here, 2 resistors over here, we've got a PTC here. So, okay, there's one PDC. I haven't seen any other MOVs or any sort of other protection circuitry except for this PDC and these 2 glass fuses. Now, I don't think that's sufficient, but let's carry on. as you go through the board, you'll see a lot of sort of slightly skew soldered on resistors, capacitors, diodes, etc. in various positions on the board. Okay, here you see the back end of the rotary switch. Again, the build, I don't know, it leaves a lot to be desired, but let's move on. If you can see this here, you'll see, let's see how close we can get before this camera defocuses. Come on, you can do it. Nearly. There it is. Okay, if you see here, you can't really see it too well. You can see how the residue from the soldering is all over the place. And another thing that I don't like is, if you look around here, you'll see these variable resistors, which I assume are used for some form of calibration. I mean, I can count 1, 2, 3, 4 of those small little guys on the board over there, around some ICs which I can't get in close enough to see, some transistors, diodes, etc. As you head on further up the board, you'll notice here you have a capacitor of sorts, crystal or reference oscillator or whatever the case may be. Inside here you've got some form of variable capacitance. There's 2 of them inside there. I'm not sure what they're actually for. And then over here you've got a very big multi-turn pot, I'm assuming for some form of calibration as well. And as you head to the top of the board, you have most of your logic control ICs, etc. Stickers over, covers over. I'm not going to bother pulling these covers off, because I'm afraid when I try and solder it back together, something's not going to work again. And this meter does work, I must say. And then, oh yes, here you have the 2 contacts for your buzzer. So all in all, I'm not really liking the overall sort of quality of build in this meter. Now I'm going to show you guys an image of another meter shortly, which is one of the Unity Pro meters, and then you can do a comparison between the 2 and see exactly what I'm talking about when I say things here are not that great. Let me see if I can print the other board layout, and then we can talk about it. Either that, or I'm going to just pull it up in the computer and we'll go through the components and talk about how it's put together and the difference between that meter and this meter over here. The people that know me know I'm not a brand slut or anything like that, but I've never been particularly impressed with the overall build of these multimeters. I do enjoy this meter from the sense of its accuracy is pretty good for what it is. I mean, if I was to put it next to any of my other meters, you would yield a really good result. I mean, right now, just talking about it, if I was to throw some leads in and connect it to my 3.3 volt high accuracy reference, we would probably yield a 3.3, yeah, there you go, 3.3007, and coming down a little bit higher than it should be, but my point is it's accurate and I've never had an issue. For bench work, possibly, yeah, why not? For bench work I think it would be alright. When it comes, however, to high energy work, I would definitely not use something like this on a high energy circuit, because that would just purely be looking for trouble, in my general opinion. And quite honestly, it doesn't matter what your opinion is, you will get hurt if this meter is used on high energy. I'm not saying all the Unity UT71Ds are the same, or that all the Unities are the same, but I'm not sure if these are Chinese spec. Some of the meters I've seen from the local agency for Unity were definitely not on par with this with protection. They were much better built, and the protection circuitry internally was much superior, far superior to what's inside this device here. But we're going to take a look at that now, and you can draw your own conclusion. Hey guys, so I'm just going to quickly open this up. Just using Photoshop because it's easier to move around, etc. And we're not going to show you too much detail about these meters, but what I wanted to show you is the input and protection stage. As you can see over here, this is a Unity meter. It is one of the Pro meters. I'm not going, like I say, I'm not going to show you too much yet until I get permission. but if you look, you've got the input terminals. It's still a single strap, but with a screw down, it's a hell of a lot better than what Unity have done in the past. We've got two large blast fuses, sand-filled, whatever you want to call them. We've got 4 PDCs, and we've got what looks to be 3 MOVs, as well as the 2 fuses for circuit protection. Now the differences I see here you have the 10 amp current shunt, and it's clear. I mean, here you've obviously got one of your terminals goes through your 10 amp current shunt. This will be your measuring point. Now, as you can see from your current shunt, you've got your measuring connection coming off here, going through to whatever circuitry is required there. And then you've got a nice thick track coming through here, through your big fuse and to your terminal. So these two would be connected perfectly through that fuse and current shunt. Happy days. Please excuse the knocking in the background. You always have some twat making a noise around here, so those sort of things happen. But anyway, here again you have the same thing with the fuse, etc., with the same sort of measuring capacity, and obviously your volts input. Here you've got all that protection circuitry sitting there, and of course, yeah, so fantastic. I must say, Unity, very well done on this meter, and things are looking a lot better. The only thing I see that could be missing, being I think this was an engineering prototype, is that there possibly could be an RF or so like a RF shield over here, some sort of a steel box or something keeping this componentry, and maybe it's not needed, but I think that would have finished it off quite nicely. This ribbon cable here looks synonymous of the Fluke 189 actually. But anyway, as you can see, the quality of Unity can be made very well. It just depends on what market they're making them for. So yeah, guys, that's pretty much just a quick comparison. This meter will be reviewed soon, so I'm not going to mention what make and model. All I'm telling you is it is a Unity Pro range. Just coming back to the UT71, somebody on the EEV blog recently posted something quite interesting. Which was a full review of the UT71D. What's it? It's white knuckles by the look of it, and the link to that is available here. It's eevblog.com/forum/test-gear/uni-t-UT71D-review/. And this is quite an in-depth review, so we're going to go back now and down to the board where he's already listed most of the parts for us, and between the two you can see there's quite a large difference in the construction quality of these two Unity meters. So yes, there seems to be two production standards, this being the one and this being the other. Now going through here, he's nicely labeled the board for us, so you can see you've got your memory EEPROM chip, NAND gates, T1 microcontroller, LCD driver. That's what that guy is with a sticker stuck on him. Those things that I thought were capacitors may possibly be precision resistors or some capacitors, I'm not sure. Like I said, I didn't pull these covers off, and I'm not going to because it's a bit of a procedure. Precision op amp there. We've got a voltage reference, this guy over here. So that'll basically be what the thing references against. Now this multimeter does have a closed case calibration, and of course you can use these pots to do calibration, but I recommend the closed case, as does everybody else, as does the manuals, etc. Anyway, okay, so here you got the true RMS converter, you got a couple of op amps, 5.5 and 3 volt regulators, things to look for if something goes wrong. PDC, like we mentioned, there's the one PDC, the two. We've got a protection Zener diode here. I'm not sure where it's connecting to. Then we've got some microamp milliamp protection diodes here, and it looks like these resistors are also something to do with protection, possibly current limiting, or something like that, sort of, or voltage dividers. I'm not sure what they're being used for. I haven't looked at the schematic diagram for this thing properly, so I don't know exactly. And then of course you've got a Kairos Tech IC reverse side, apparently. Yeah, so it's quite interesting when you see how somebody's done this. Oh yeah, we got some more current shunts here. Yeah, it's quite an easy layout, quite a simple multimeter. In fact, most multimeters are pretty simple when you actually start referencing the ICs online, etc. It's easy to find out what is actually doing what, etc. Just by doing a Google search for the part number, etc. You'll know exactly what it is. So again, nobody seems to know exactly what this is, but again, I think this is something to do with calibration. I'm not sure. Maybe one day when I'm bored, we'll turn that and see what happens. But yeah, that's pretty much it, guys. A bit of a follow-up of the UT71D, and just to wet your whistles a little bit about the Unity Pro multimeter, which we'll be doing a review on shortly. Thanks for watching.